Hi everyone, I'd like to thank you for joining us today for our webinar, Ansible for iOS Build Benchmarking. I'm here with developer Jeff Vincent, who will be leading the webinar along with MacStadium's iOS DevOps coach, John Cabaniss, MacStadium's Daniel Pierre-Louis, and MacStadium's Daniel Pierre-Louis. And last but certainly not least, I'd like to introduce our special guest, developer of the Mac Development Ansible Playbook and the author of Ansible for Kubernetes and Ansible for DevOps, Jeff Geerling. Just one more announcement before we get started. We'll be giving away a copy of both Jeff Geerling's books. Please stick around until the end of the webinar and we'll select 2 winners. You can email me, Stephanie Urbisfield, at hello@macstadium.com with your information following the webinar if you're selected as a winner. Just as a reminder, you will be muted for the duration of this webinar. If you have any questions for anyone on the webinar, please put them in the chat or questions pane and we will get to them at the end of the webinar. We'll do our best to answer all questions, but if we run out of time, we will get back to you after the webinar. Now, without further ado, I'm going to hand things over to Jeff Vincent.
Hi everyone. Thanks for being here today. This is a real treat. So the object of today is to first go over the basics of Ansible. So we'll first introduce kind of like these four core pieces. So installation, setup. We'll actually talk about 4 core components of Ansible briefly, and then we'll talk about a couple of connection types that you might run into, but specifically we'll focus on one of them, and that'll be SSH, just to let the cat out of the bag. And then finally, once we've done that, we will apply that learning to getting Jeff Geerling's Ansible Mac Dev Playbook set up and running against MacStadium VMs, just as a kind of a stepping off point. And from there, we'll kind of open up a conversation around how this technology is used, or how we see it being used at MacStadium, and how it's used internally for benchmarking and potentially some other processes too. So, introduction to Ansible. Let's go on down. Ansible is, just as a brief overview, Ansible is a configuration tool. It kind of in the same vein as a number of other configuration tools out there, but it's generally considered a modern tool because it utilizes YAML to describe the various workflows. So it's very human readable, and it has some other kind of neat benefits too, and it's particularly lightweight when it comes to deploying it. So that's really neat. And so that lightweight quality starts kind of shows itself pretty quickly, even when you go to install Ansible. So Ansible is written in Python, and as such, the preferred means of installing it, particularly on Mac, is to just use the Python package manager pip. There are a couple of kind of nuances that are emerging there because of deprecations of certain Python versions, and we'll talk about that briefly when we go walk through the installation. Yeah. In fact, why don't we just go ahead and start there? Jeff Geerling, are you able to speak on this deal?
Yeah, definitely.
Oh, excellent. We had an interesting chat when we kind of ran through this, and I was hoping we could kind of like recapture that here for folks. Like, how do you approach your Python versioning kind of setup when you go to use Ansible?
Yeah, the first thing that I do with any new Mac that I am setting up is I install Homebrew on it, because Homebrew is useful for so many different things, but even for installing Ansible to automate the rest of everything. So I install Homebrew, and then I use Homebrew to install Python 3. And the reason I do that is the system Python that Apple ships in macOS is Even if you use the system version of Python 3 in the latest macOS Catalina, it's not ideal to use that. There's all kinds of little problems that can happen. So I always install Brew, and then I say Brew install Python, and that gives me a good Python and a clean Python to install other things with.
Awesome. Yeah, when I heard you say that, I was really encouraged. Just as a kind of like full disclosure, I work with Python, but I'm relatively new to Ansible. So what I'm able to share today is kind of like what I've gleaned from my bumps in the road, as it were. But that's really neat because that's exactly how we ended up approaching this today. So anyway, to demonstrate what that would look like, you would first install Homebrew, which is just a simple, it's a single line that you can copy and paste from their website right into your terminal, and it will install. Once it's installed, you can brew install Python, and what this will do is actually give you the latest major release of Python, which in this case, as of right now, is I think 3.9 is technically out, but 3.8 is what it'll end up with. At any rate, so while that goes along, maybe we'll wait for a second. Okay, cool. So I've got 3.8 installed, and it's already up to date because I've already done this. But had I not, you would see it install there. And then once you have 3.8 or Python 3, a new version of Python 3 on the system, in my experience, the simplest way to make sure that you're not accidentally installing against one Python version and then trying to run it in another and then getting kind of weird echoes of errors and you can't quite pin down what version is running what, just make it explicit. So I can see that I have, so I'll make it even easier. So if you enter an interactive Python terminal, you'll get your version here, and we're only interested in this major release. So we're just looking at 3.8. Oops. Let's see. Right. And to make that explicit, when we go and run the pip, like the pip install command, we can use this specific pip module that came with this Python version. So we can run pip that way. So explicitly against this. Which it already has because I've already done that. But what's neat then is now you can run Ansible and you know without doubt that it's running against the system installation of Python. So you're not going to end up with any squirrely errors, which is just in my experience of like making everything explicit helps to track stuff down later if you run into anything. So anyway. With all that said, now we've got Ansible installed. That really is kind of, in my opinion, one of the neatest parts of Ansible is that it only needs to be installed on one machine, and that's the machine that you're going to be using to control everything. We'll call it our controlling server. But yeah, that's the only place Ansible needs to be installed. It doesn't need to be installed anywhere else, unlike some other configuration tools that might need to be in place on both ends, right, on the target and the controller. That's not the case with Ansible. Right, and so that kind of moves us right along to the idea of target servers. So we have, with a configuration tool like this, you have kind of a central location that's going to be pushing updates out to any number of other machines. The controlling server will be that, and it could be anything. Because Ansible is pretty lightweight, this could run very reasonably on a laptop. It could also run on a VM in the cloud. It could run, anywhere you like, but it doesn't take a whole lot to get this up and running on any particular machine. So again, a laptop would work fine. But then from there, today our target servers are going to be MacStadium hosted VMs, which I'll show you in a second. We'll use Orca, MacStadium's product, for orchestrating with Kubernetes in the cloud on Apple. At any rate, it's a pretty neat tool. But that's where our target servers will live today. And this will all kind of become more cohesive when we start getting into the kind of the meat of it. But so with Ansible running on one machine, it needs a mechanism by which to know what the machines it needs to operate against are, like where they are, what they are, where they live. And that's what the inventory is. So the inventory is a plain text file. It lives on the controlling server. And at its most basic, it is just a list of IP addresses, like absolutely just a single, like nothing else to it. And Ansible will accept that, and it'll work with that. We've made some changes to that formatting today, and I'll explain why when we get there. But yeah, that's what that piece is. There's the inventory is a plain text file. It lives on the controlling server, and it tells the controlling. It's just a list of servers against which Ansible needs to go run. Right. So once that's established, once Ansible picks up the inventory and parses it, and it goes and goes to work, right, on these target servers, it needs a list of commands to execute. And in Ansible, that list of commands is called a playbook. Playbooks are written in YAML. They are essentially like any other kind of like staged kind of orchestrated process description, right? So there are, normally speaking, and I'd be interested, Jeff, to hear your how you approach this, but normally speaking, so there is a playbook, right? A playbook is a collection of instructions that Ansible will carry out, and a play is a subset of that collection of instructions. And usually, a single play might be a collection of meaningful actions that we would want to track the outcome of. So, for example, it might be install a piece of software and configure that piece of software, and I would like a result as to how that overall, that larger process was, went. Was it successful or not, or what's the status of that? Jeff, how do you approach the organization of plays in your playbooks and things?
For the most part, I would have one play, especially if I'm just managing one server or one set of the same identical type of server. Sometimes there are playbooks where I'll have multiple plays, but that's usually when I'm doing something like the first play sets up, it provisions new servers, maybe using Orca or something else. The second play runs things on those servers, and then the third play might configure something on them or deploy something else or notify me of something. So, but most playbooks just have one play. And then the other thing that I do when I'm building them is I'll usually put all of the things, all the descriptions of what to do. In Ansible, it's called tasks. I'll put all those into one play in one file. But if the playbook starts to become more than like 100 lines or so, that's where my brain just can't hold it all in. I'll use some other features of Ansible to split those out. You can include other task files in a playbook, so you can break things out that way. Or you can use something called roles to break groups of tasks into separate directories that you can either share with other playbooks, or even if you're just using them with one playbook, just ways to organize things better once you start having more complex playbooks.
Great. Maybe if we have a minute at the end, we could take a peek at the roles piece and that that might be neat. But thanks for that. That's cool. Okay, so so to recap briefly, the components are very simple. The machine controlling it, the machines being targeted, a list of the machines being targeted, and a list of instructions to carry out on those machines. Pretty straightforward. The way that Ansible makes these connections, it can be, there are a variety of ways, I suppose. What we'll focus on today, and what is, I think, most common for this type of work is SSH. But there is a local connection type, which would allow Ansible to run against the controlling server itself. So if you, for some reason, needed to configure, if you're like setting these up regularly, Ansible would be an excellent tool for that. Like if you were right. And again, this could be really beneficial if it were like a one-off process with an awful lot of machines to be configured, or like a repeated process where you've got the same things to do on relatively few machines, but over and over again. Makes Ansible a great candidate. Jeff, can you talk a little bit about any other connection types that you see or that you think folks might be interested in?
Yeah, the main one that I usually use is SSH, just because you can connect to almost any server, at least any Linux and Mac, and even Windows now has SSH built in. But local, as you mentioned, is what I use if I'm managing the machine itself, the machine that's running Ansible. So sometimes I'll do that. But the other one that I use frequently is the Docker connection type, because you can actually connect to and manage Docker containers using Ansible, which is helpful for doing container work or working in Kubernetes, that kind of stuff.
That is really cool. I actually did not know that existed. I'm gonna go learn about it. Cool. Okay, and then today, for our purposes, we'll be using password-based SSH, but key-based is generally considered a best practice. So just a brief call out there. But yeah, with that kind of out of the way, let's get into a demo and see what this stuff looks like. So first, let's get rid of all this stuff. I've got this Orca Cli up here, and just a kind of a brief kind of summary of how this runs. This CLI, it allows you to spin up and tear down Mac VMs in the cloud with MacStadium. Yeah, it's a pretty neat tool. I'll just run through it real quick. So our objective today is to create a VM that we'll use as a controller. And I've said 2 here, but let's just make it fun. And I've already run through this test before, so that I have a lot of confidence that it'll work, or this demo or whatever. So what I'll do here is just kind of emulate reality, I guess, or how it might really be used. And I'll have a bank of 3 servers, right? 3 targets. We'll have target 1, target 2. I'll create a new one called target 3, and then we can see how Ansible will behave when it's running against machines that are in different stages of, or different states. So like this playbook has already been run against these 2 machines, so they've been updated to that desired state. Of course, the third will not have been. So, so we'll see some varied output and see what that looks like. So with Orca, it's just a simple command. Oops. Orca VM create, and we'll call this, I guess, target 3. And doop, doop. We'll say we would like this machine to have 3 cores. And it looks to be up. Cool. Oh, no, my naming convention's garbage. Okay, so so now we've got a controller and we've got our 3 targets in place. Next, we'll need to gain SSH access into one of the machines. Now, what I'm going to do today is to go just work through a single terminal, and we will we'll be kind of like bumping further in by SSH. We'll make additional connections on top of our initial connection, and then pop back out of those, and as we work on these different machines. So, but yeah, the first thing we need to do would be to gain access to this controller. If this were your laptop, this would be not necessary. But yeah, we'll SSH in at port 8822, I think. So, so yeah, so what we ran there just briefly was just SSH and then our user at the IP, and then because our these VMs are exposed oftentimes on the same IP, but across different ports, we had to pass that as well. But now we're in here. Now we'll go ahead and this will be, I believe, Ansible should be installed here as well. Looks like it is. Okay, good. So, so the way that this VM has gotten kind of to this state is that I followed exactly kind of the same path that Jeff Geerling advocated earlier, which was to install Homebrew and then install Python, and then finally install Ansible explicitly against that Python version, so that when I run Ansible, I know where it's running and I have some control over that. So once that's done, we'll need to go ahead and clone the playbook down. Oops. Which I have already done, but it's on GitHub, and it's Jeff, it's Gearling guy, is that right? Gearling guy?
Yes.
Excellent. Okay. Yeah, so that would be where you'd go grab it, but I've cloned it down. Okay, and within this, we can just take a quick kind of look around at this briefly. We've got some configs. We've got a few different YAML files that are kind of interwoven largely. We've got this requirements.yaml, which is the collection of kind of like, now I'm blanking. Anyway, supported stuff that supports this playbook that will need to, this specific playbook that will need to be installed for Ansible to run, I guess, requirements. We've got roles, which Jeff spoke about briefly, and we might have time to revisit at the end. And these other pieces. We also have this inventory file, which we'll work with explicitly today. And we might touch another file or two, but really kind of the beauty of this whole piece is that if you can take pre-written playbooks and simply update your inventory, point it at a different server, and let it rip, and it should largely work. There may be a couple of picadillos. So that's the playbook. We are now ready to set this up according to this handy dandy blog post, which is up at MacStadium's blog, blog.macstadium.com. Right. So now we've got kind of like the basis of everything up and ready to go. We would be ready now to move on to working on getting the target servers in a state where they could accept that SSH connection that we're going to be looking to make. By default, MacStadium servers have this enabled, so we won't bother with it. But if you're working on another machine, yeah, enabling SSH on Mac is pretty simple. It's just a kind of a switch like this. So sudo system setup set remote login on. Right. The next piece that we're going to talk through briefly is, I think, as I understand it, it's kind of a legacy approach to doing this. Jeff, I understand that you made some changes recently, or maybe in the process of doing that to kind of change this. I might talk through this briefly and then ask kind of like for an update on where you are with all that.
Sure.
Cool. So right. So if we're going to go ahead and run this playbook, it's decision time, I guess. So there's a vagrant portion of this playbook that requires additional permissions for the Ansible user to be able to carry out these instructions on the target machine. And so if you choose to, if you choose to accept this mission, then this would be the way you would do it if you choose to install Vagrant. Now, the alternative, I should say ahead of time, at least the alternative that I noticed, was just to remove that portion of the play, or of the playbook, by updating the default config YAML, and simply remove that line. Where did it go? Anyway, just remove Vagrant from the line, and it seems to work just fine. It just ignores that. But if you'd like to install it, first we'll need to go one step deeper. Let's go into this new machine. It's at 10.10.10.15. And it's asking us to, to verify that we want to do this because this is a new machine. And it's worth calling out that Ansible would need to, so this interactive piece would be kicked off if Ansible were to try to make this connection before we did, before we had made it manually, because this is asking to, ultimately it will ask to add this this server to the controllers list of known hosts. And there is a way to disable that checking if that's the direction you'd like to go. But either way, you would either need to disable, I believe it's SSH key checking or something, or you need to make these connections first. So there's that. Now let's go ahead and update this machine so that it can install the Vagrant portion. We'll just save ourselves some typing. If you do go this route, it's certainly worth noting that it's a good place to pay attention. Updating the Sudoers should only be done with the sudo visudo or vsudo command, because it actually won't let you save it with errors. If you happen to make one, it'll say that's not working. Would you like to try again, basically? So, but anyway, to edit this file, we will type Shift A. Oh, there we go. And then the only change we need to make here, the admin user, so we're down in the wheel group, right? So these are the users in the wheel group, so they can run anything on any machine as any user. Ansible is acting as the admin user, and what we'll need to do is to change this line to, oh wow, that's silly. Okay, not that line. Let's see. What? Right. So looks like there's a little bit of a technical issue there. So actually, I think we'll just move on from here. Jeff, do you want to talk briefly about as I undo this, because my somehow this got edited. How are you approaching this now? And I know that you're working to kind of make this an obsolete step. So that might be a great time to learn about why we don't need it anymore.
Yeah, basically, when I built this playbook, it was maybe 2014 or so. I was building it only for my use case, and for me, I used Vagrant and I did all these things, and I needed it to be able to modify my Sudoers file and things like that. For most people, you don't need to do that. So a month or so ago, I actually I didn't remove the feature. I changed it so that it doesn't do this by default, so you wouldn't have to deal with all these things. And now if you want to modify the Sudoers file on the Mac, you can configure that, but it doesn't do it by default. So it should be, it avoids this whole process of using vsudo and editing the file and trying to do passwordless sudo and things like that. So, and there's other things too. There are a few other people who've helped me make this playbook a lot better over the years by expanding its use cases. And that's kind of the joy of open source sometimes, when I put something out there and someone else takes it and makes it even better. Especially there's a couple roles that it uses that we've talked about a couple times, and a couple of those roles were written by people who aren't even like totally separate from my work, but they work together because they're written in a generic way.
Very cool. So which roles kind of have or is this something that's an ongoing process for you? Do you work with folks kind of do you ask for contributions for this kind of stuff, or is it just people kind of pick it up and then share what they've done with you?
Yeah, I typically don't ask for anything, but enough people have used it and found it helpful that they've improved it and sent me contributions. But one of the roles, the I think it might be the Homebrew role or the Mac App Store role. One of them depends on a command line tools role by a guy named Elliot Weiser, and he's helped a lot with little issues here and there over the years. So it's a great thing about this project is it's gotten better over the years, and hopefully, you know, a year or so from now it's even easier. And I actually just merged in a fix today that makes it easier for you to use it on remote servers. Makes the inventory setup a lot simpler.
Ah, very cool. Right on. Cool. Okay, so I think what we'll do is we will get to see some failure output alongside some success output because yeah, and that'll be worth seeing, I think. Right. So now back to the controlling server. We've already we've installed Ansible. Because today we are going to use password-based authorization for our SSH connection, this is a requirement. Simple brew install. And then once that's done, we will we'll jump into the inventory file. We will this is what it's going to end up looking like. We've got so as I said earlier, it's literally just a list of IP addresses that define the target machines. This convention of giving the machine like a human readable name and then passing a port and then passing the IP seemed to work best for us because, as I said earlier briefly, with MacStadium, a lot of the time there will be a number of VMs exposed on the same IP or stood up on the same IP, but they are exposed by port. And because Ansible, guys help me out, I think the default port is 22, is that right?
Yes,
The default
yes.
connection port. Yeah. Cool. So in order, at any rate, in order to get Ansible to pick up the port and not try at its default port of 22 against the IP address, I found that I needed to pass the port first. It seemed to like that better for some reason. But beyond that, we've got only a couple of connection pieces here. We've got our connection type, we've got our username, and finally our SSH password. So let's jump in and make sure that looks like what we want it to look like. So we've got all that stuff in place. We've got these two machines. We're going to go ahead and add the third that we created and go from there. So you lived at 10, 10, 10, 15, 88, 23. And you are actually number 3. Okay, so again, that tells Ansible what machines to work against. Next, as I mentioned briefly, this, and Jeff did as well, this playbook was originally written to run against the local machine. So in order to change that behavior, you'll have to go into the main.yaml file and remove, it's on line 3, just this simple line, and the result would be the following. Just omit or comment out, whichever you prefer.
And that's the thing that I just fixed today. So
Oh, is it really?
as
Oh, cool.
of today, you don't need to do that part anymore. You'll just need to
Oh,
make sure your inventory is like you said a minute or two ago.
oh, hey, well, shoot, that's pretty neat. Um, it's a living thing. It's a living
Yeah.
thing. Okay. Cool. And then briefly, I mentioned this. If you didn't want to take the time to go and manually add each of the target servers to as a known host to the controlling server, you could set this in the Ansible config, just a host key checking to false. Jeff, what can you speak to any kind of like security pieces included there, or maybe any alternative routes to getting this done?
Yeah.
Anything? Yeah.
Yeah, usually I leave it on and I just have I either manually log into the server the first time ever to get the host key,
Hmm.
or it's not the end of the world, I don't think, to turn off the host key checking. The main thing that it protects against is if you connect to it once, your computer knows that that server has that host key, and if you connect to it again next week and you get a different host key, then you know
Mm.
that something happened. Either somebody hacked the server or somebody redirected your server's IP address or something. So it is a useful security measure. And so I typically leave that on for anything that I have in production. And
Mm.
there's other ways of getting the host keys off of your servers. Like you can run Ansible, you could build a little playbook that runs separately that pulls the host keys off your servers the first time that you set them up
Mm.
and
Mm.
download them. So there's a few different ways to do it, but yeah, it's one of those things that for development purposes I don't normally have it, but for anything in production I would still leave it on.
Gotcha. Cool. Cool. Um, so we'll go ahead and leave it in place because we already made that connection manually. So no big deal there. But yeah, that's good to know. The next piece would be to go ahead and run Ansible Galaxy install recursively requirements.yaml, which we touched on briefly. When you run this, you get some Ansible specific output. This is already on here, but that's sort of what that might look like. And now I feel like I almost kind of, it feels like that was too fast, too easy. But theoretically, we should see this work now. Again, we'll see a failure on target 3 because of the vagrant portion. But now I guess finally we are ready to go ahead and run Ansible Playbook, which is the command, right, to run playbooks in Ansible. Give it the main.yaml, which is kind of like our core entry point to the playbook itself. We'll pass it the so this takes a flag because not everyone calls it the inventory, just as a call out. I think I've seen hosts, maybe I've seen some different things. So this is I think conventionally pretty common, and it is a common convention. But anyway, pass it the inventory, and then finally we'll pass it ask become pass, which is kind of an interesting thing, I guess. So Ansible is going to ask you to become the sudo, or yeah, the sudo user of the target machine. So it'll ask for like it'll be probably your SSH password. So yeah, let's go ahead and run that. So, just to kind of like briefly talk about what is going on here when you run an Ansible playbook. The first thing it does is it goes and gathers facts. So you can see here that it's checking against all of the machines, and it's doing this in parallel. So so it's actually pretty fast. So yeah, and other folks on this panel, can someone who's used this at a larger scale speak to like performance at scale and that kind of a thing? Like what kind of how fast could we expect this to be running if we were on, you know, X number of machine, we were working against X number of machines. Do we have a sense of that?
There's a few different considerations for performance. One thing is the facts get a lot of data about the machines, like how much RAM they have and their CPU and the architecture and what version of macOS. So if you don't need all that information, you can actually turn the fact gathering off, and that's a little faster than. But if you do need the facts, it's important to have them. There's a few things that you can configure in Ansible's SSH connection settings to make it faster. And also just in general networking, it's always best to run the playbooks on a machine that's within the same network as the machines you're managing, if you can. So a lot of people who have a lot of servers, let's say inside of MacStadium, it's nice to have one of those servers be the controller instead of controlling it from another computer far away, just because the networking performance can be better that way. But
yeah, that makes sense.
I've run the playbooks on up to 100, 200 machines at the same time, and it, as long as you have enough memory on your computer, you know, 16 or 32 gigs of RAM, if you're doing that many, you can do all of them in parallel still, and it'll still work fine.
That's pretty neat. Ansible's a pretty neat tool. I've come to be pretty darn sold. Cool. So at any rate, here we've got some output. You can see that as Ansible goes and interacts with the target servers, it'll check their state for each of these tasks that it's going to you know, potentially carry out. If that task is already, or that the state that task would achieve is already in place, then it'll skip. It may say okay, and it may ignore things. If it does, this is kind of the output I was expecting. So it'll say the first two machines I had up had already been run, like this playbook had already been run against those machines. So it skipped both of those, but changed the third, and so on. So that's kind of Ansible in a nutshell. I don't know, John Cabaniss, if you wanted to talk briefly about how folks internally at MacStadium are using Ansible.
Sure. So we are a big Ansible shop in general. Ops and dev both use Ansible routinely. We use Ansible to provision clusters as well as add nodes and other functions like that. But the benchmarking and quality assurance teams have been using Ansible for a little bit now. We also have Daniel on the line, who's one of the active members, originally from the QA group, and now he's on the benchmarking side. One of the things we do with the task system and breaking out subfiles is we'll have each task is tied to a different benchmark. And that lets us have a lot of different owners for each task, not necessarily due to length, but really assignment and getting multiple people involved. And I think that's a function of how many people and how much dev we've done in a short period of time. I'd say we got about 15 or 20 different employees who have touched the scripts since they were first brought up, and that was done pretty short time frame, 3 to 6 month kind of a frame. Jeff, how many people have really worked on your playbook over the years?
Just looking at the contributor list, it looks like there's about 8 people that have worked on this project, but probably about 10 or 12 total and this was from 2014 to today, probably 10 or 12 on all those different things that make up the playbook.
Yes, that's a consideration, is the amount of people. The other thing that having a lot of tasks gives us is the ability to run simultaneous stress tests. So instead of running one single task in a task by task order, there's a feature where you can run a task and not wait for the output and run a second task. So this lets us run the same task in the same machine and do 2 benchmarking runs for concurrency, and that gives us more flexibility. I'd say the biggest thing you got to look out for is exactly what you have on the screen right now. A lot of times fatal errors, if not properly coded, which they are in Jeff's playbook, can end an entire Ansible playbook. That's obviously not desired. Oftentimes, you can, in a virtual environment, you'll have errors crop up, things happen, as happened today, and you want to have the ability to ignore things and move on and finish the benchmark and then look back at it. You might have a case where you spin up 10 VMs and one of them is bad for whatever reason, it doesn't land properly, and you want the other valid benchmarks to proceed, given that, and get as much information out as you can in a short period of time. And then you can evaluate what happened with that 10th one, and if you want to keep that.
I think I could speak briefly to that as a noob. To Ansible, I initially thought, oh my gosh, only one one task failed. That's a pretty good run. But then in addressing that one failure, it opened up this was in a different playbook, but anyway, it opened a whole series of tasks that had not been executed because that first had failed. So as a call out, a single failure does not necessarily equate to a truly single failure. Yeah.
Right. And Daniel, you want to comment on the innovations we've had with the benchmarking scripts, or where the value adds that we've really focused on?
Sure, yeah. So we pretty much use the benchmarking scripts to, well, first we spin up our Orca virtual machines, and then we leverage those to use our golden benchmarking image that we pretty much have like Xcode builds in Java. And then from there, we run our Ansible Playbook, which executes the benchmarking scripts on whichever specified VMs are in our inventory file. And from there, a series of tasks are ran, which pretty much instruct Ansible to run the jobs that we need ran and then check on them until they're finished and grab whatever results we need off of them and placed in our database. That's pretty much.
So it sounds like the constant checking is the big value add there, separate from what Jeff's basic playbook does. Also, I've passed out Jeff's playbook a lot. It's a great start. It's very common dev tools. People find it easy to modify. Now, we're MacStadium, so we do a lot of virtualized instances. We have a lot of bare metal customers too. But in general, when I'm passing out his playbook, it's for a virtualized setting. So I've seen his playbook used and modified, either forked or downloaded and customized to do a virtual environment pretty easily. So thanks, Jeff. You did a great job.
You're welcome. I'm always happy to see people use it, and I strongly encourage people, if you find it and it does 90% of what you want, just grab it, take it, and change it to do that last 10%, because that's why I make all my code open source.
It's very much
Kudos
appreciated.
for that. Yeah, that's right. I think so too. Yeah, that's excellent. Okay, so any kind of parting thoughts before we open up to questions? Anyone? Sounds good. Stephanie, do you?
Yes.
How would you like to do the questions portion?
Yeah, I have a few, and I'd love to read them to you guys and just go ahead and answer them as needed. So the first question we have is, don't need exact metrics, but curious how much more efficient the MacStadium team has become leveraging Ansible.
That's a good question.
Well, it depends on the department. So we used to do, before we really got the full Ansible script working, I'd say we were spending, provisioning a new Kubernetes cluster is time consuming. So we never did it fully by hand. We would always use KubeADM or one of the other tools. But then the QA process is also an addition. I'd say we went from about a day provision time for a new private cluster. And by the way, we only do dedicated infrastructure. So every Kubernetes instance we do is dedicated for one customer. We don't have one big cloud. That went from about a day to 2 days, depending on if you had a QA problem, to about an hour now. So that right there is massively a massive improvement. And that hour includes QA. So we're really looking at a 10 or 15 minute setup time. Benchmarking, we used to run erratically since it was mainly by hand. So when someone had time, and our benchmark clusters were fairly underutilized, you might see a 20 or 30% utilization. These days, Daniel frequently fills up clusters for a week of solid compute at a time, 24/7. So in that respect, we got a lot more data. It just kind of depends on where we are in the cycle and what's coming and going. But that kind of number, a factor of 30 to 50 more efficient would be what I would throw out there as a good guess.
Nice. So to summarize, it went from a couple of days to standing up and provisioning a private cloud to an hour. Was that the breakdown?
Yeah, that's accurate.
Yeah.
And
Cool.
the usage of our benchmark cluster to give metrics is also increased by a similar factor, somewhere between 30 and 50. So we're active now for 30 hours to every 1 hour beforehand, roughly.
Cool.
Okay, so our second question is, what do you actually benchmark? What data do you collect and how do you process this data?
Okay, so right now we're collecting 2 time outputs. One is a general time that includes some wrapper logic from Java and Python to launch Xcode. The second one is the Xcode temporal output. We just did a webinar on this, have introduced monitoring of CPU, RAM, and local disk read-write, as well as requested read-writes and average time to write a block. And that's, I don't think we have a link here, but that's in the open source github.com/MacStadium. And then you'll see macOS monitoring. Those are all the tests we run in addition to the Xcode builds. We have 10 different Xcode builds that we picked based on various criteria. They include the Wikipedia iOS, as well as AudioKit, DuckDuckGo, and 7 others. And we picked them to try and be representative of our customers' builds.
Fantastic. So our next question is Ansible versus MDM for managing clusters of Macs. Should you use both or just one?
Well, there's no harm with using both. I would recommend a strategy where you use Ansible for your setup. And then if you're going to go MDM, that really is a moving forward configuration management system by Apple. So if you're going to use that, you would not use Ansible on a routine basis. Now, you could use Ansible to help config as long as you had access to all the machines. In the case of a workforce, you generally don't want to just randomly SSH into their machine with Ansible and kick a runoff. MDM is better for that. In the case of a bunch of automated machines or like our benchmarking clusters, using Ansible is just fine. There's no need for MDM if there's not a real user that needs to have input on when updates happen and when their computer shuts down.
Great. We have a few more. Do you guys have time?
Sure, I do.
Does MacStadium have any plans for building any kind of Ansible collection or other integration? For example, an Ansible inventory plugin that could automatically identify MacStadium servers?
It's funny that should come up because I think Jeff I think you floated a similar idea. Just curious.
Yeah,
John,
I actually am one of the maintainers of the Kubernetes collection and have worked a lot with the Amazon AWS collection, and it is nice sometimes to be able to get that data straight out of Ansible, so you don't have to manually sit there and build up your inventory script, especially when you get 10, 20, 30 servers. It gets to be a pain to manage that file by hand.
Mm-hmm.
Yeah, I don't think there's any formal plans to do that, but we have started. There is a MacStadium rollout there, as well as an inventory playbook, which gets some use mainly by our internal teams. I think Jeff is a better repo in general. A full plugin is not quite on the drawing board yet, but as you just heard, people are talking about it now, so it may come shortly.
Great. How do you recommend I modify Jeff Geerling's playbook? A private fork or a pull request to the main repo?
That's a good question for me, I guess. I typically encourage, if it's something that you're just going to do for yourself and like installing or configuring one application that's special for you, I would just do a fork of it. If it's something you think a lot of people would benefit from, I do accept pull requests selectively, mostly because I do run this on my own machine, so I'm not just going to merge anything in if I don't necessarily trust it. But one other thing that I try to do is make the playbook adaptable by default. So that was one of the things I merged this morning, was a fix for the inventory so that you can control local machines or remote machines without having to hack that main.yaml file. So if there's changes like that that I can make to make it more flexible, I would love to do that.
Fantastic. I think that this is probably going to be our last question because we're running up on time and I want to do the giveaway, but we do have a few more that I think that we can answer and put up in a blog post. So just keep your eyes peeled for that. Our last question is, what are the cons of using Ansible in a Mac environment?
Well, I think the biggest con is use case dependent. You've got to use the right tool for the right job. So you've got to look at what Ansible does well and what it doesn't do well. For example, dynamic variable pools is difficult in Ansible, as is direct curl calls. They're tricky. Once you have a pattern down, you can apply the tool. But if you've got a series of things that really Ansible's known to not be good at, then it's not a good idea in any environment, whether it's Mac or bare metal. I think the push concept that we've got here is the best use of Ansible. Then you're not messing around with an Ansible agent on every VM. If you want an Ansible agent on every VM to do a pull concept, that is a harder setup. I'm not sure I would recommend that versus the push concept, which Ansible is built for in the first place. Pull does exist for Ansible. It's just more difficult.
Awesome. So as I said, that's all the time that we have for the questions, but I'm going to go ahead and announce our winners of the books. That will be Emmanuel B. and Harold A. If you guys won, go ahead and email me at hello@macstadium.com. and we will get those books sent out to you. Do you guys have anything else on your minds before we end this webinar?
No, I just like to say thank you, Jeff, for joining us today. It is a real treat to have you here. I really appreciate your contributions to the open source community, and obviously these are some pretty nifty tools.
Yeah, thank you. Thank you so much for having me. I've always followed MacStadium and very closely to see what kind of new things are coming down the pike for Cloud Macs.
Cool.
Good
Great.
to hear it, and great to have you, Jeff.
Thank you all for joining us today. Thank you, Jeff Geerling, for joining us as our special guest. If you would like to watch the webinar again, we will be uploading the full webinar to our YouTube page, so be sure to subscribe to stay up to date. Thanks again, and I hope you'll join us for the next one.